Hi, I am M. Jagadish, Associate Professor in CSC Department. In this session, we discuss about abstract class. In object-oriented program, there is a special functionality related to the abstract class. First of all, we just come to know what actually the abstract class is. When we can say one class as the abstract class. See, whenever if a class contains at least one pure virtual function, then you can call that class is nothing but abstract class, because the abstract class contains one or more functions with which there is no definition. If there is no definition, you can call that is nothing but a pure virtual function. And we are not going to create any objects for this abstract class. Why? Because means the nothing will be done. Even though if you are not create any objects of the abstract class, we can create pointers and references to that abstract class. With these pointers and references of the abstract class, then we can support runtime polymorphism. This makes to allow the abstract class to support a runtime polymorphism, which is done by means of the base class pointers, which refers to the appropriate derived classes, which makes to work as the virtual functions properly. Now, look at this, how these virtual functions and how these abstract class will works. Now, assume here we just go to create one abstract class named as shape, and in this class we just go to specify a pure virtual function named as find underscore value and a protected attributes named as value, and also we just go to create the derived classes from the shape class. Those are nothing but cube and sphere, and this particular one also consists the attributes like side and radius. And here we just go to implement dynamic polymorphism, that is nothing but runtime polymorphism, to find the value of the cube and sphere and display the results. See, when we just go to do like this by means of abstract class and virtual function, how it will work? Look at this. Now here, first of all, I am defining a class. The name of the class is shape, and in this class I declare value under the protected section with the double data type, and also in the public section I just go to specify a pure virtual function. So virtual void find underscore val is equal to 0, which is nothing but a pure virtual function. Then close the class, then derive a new class with the name cube. So class cube colon, and I am deriving a new class cube from the shape, that too under public modes. Then again in this cube class, in the protected section, I declare side with double data type, and in the public section, I just go to declare the cube function, and also void find underscore val function. This find underscore val is nothing but a virtual function which we specify as a pure virtual function in base class. Now again, we just go for one more derived class. Now here, again I am deriving a new class sphere from the base class shape, that is nothing but abstract class shape, by means of public modes. Under the public mode I am deriving, and again in the protected mode I specify radius data member, and in the public section I specify a sphere function, that is nothing but a constructor with class name and function name both are same, so it is a constructor. Then again I just go to specify a virtual function, that is nothing but find underscore val. Then here I just go to specify cube scope, cube that indicates here I just go to define the constructor cube. In this I specify cout at the side of the cube. Then through cin I simply enter the side value. Then again I am defining the constructor like sphere, sphere underscore sphere. Then in this function I simply specify the radius of the sphere, enter the radius of sphere. Through cin statements I enter the radius. Then come to the next one. Here I just go to find the value. So to find the value of the cube, I'm using a statement like void cube scope find underscore value, because this find underscore value is a function in the cube class. Then to calculate the value of the cube, here I am using the statement like side into side formula. The result will be stored in volume variable, and simply I am printing volume of the cube on the output screen. So this will be displayed on the output screen. Then again I am defining a find underscore val function, which is there in the sphere, which is used to find the volume of the sphere using this formula 4 by 3 into 3.14 into radius into radius into radius. I just go to calculate the volume of the sphere and stored in volume variable. See out volume of the sphere is, and simply it appeared on the output screen. Then close the function. Then go to the main function. Then in the main function here I am creating the pointer object. That is nothing much pointer PTR. So this pointer PTR is nothing much the object of sphere. Sphere is nothing but abstract class. So in this particular one, I am creating the pointer object. Then again, I just go to create the normal object cube to the cube and normal object sphere to the sphere class. Now observe here, PTR is equal to address cube. PTR is equal to address cube means just that indicates I am pointing the PTR objects. That PTR objects I am pointing to the cube class. Now PTR arrow find underscore value that indicates it is going to execute the find underscore value which is there in the cube class. So automatically just go to specify to find the value of the cube which will be displayed on the output screen like this. Similarly, PTR is equal to address sphere that indicates now PTR object, pointer object is pointing to the sphere class. So PTR arrow find value which indicates that now this PTR pointer object is pointing to sphere class function. In the sphere class function, find underscore value is going to execute, which is going to calculate the sphere and print the sphere value on the output screen. So likewise, it just go to specify the value of cube and the sphere will be printed on the output screen by means of abstract class and virtual function. This is the way how we just go to work with abstract class and virtual functions. Thank you.